Welcome back. I've put the cat outside, so hopefully it won't be quite as distracting, though I can still hear it meowing a little bit. Sorry about that. Alright, I've done a few other things in the break. One of those is I named the models in this list. So I put M1 equals M1, DT1 equals DT2, and so on. And what that does is when we create this table with model cell, we get the row labels here. Good. So we can actually see which models are the nice ones. I've zoomed back in so we don't get it all on one in one row. But here we see we get down to a model. The model DT10 is within 3 units. DT10 had 10 variables removed. And it's within 3 units of AIC of the very best model, and that's not much difference. 3 units AIC is not that much difference. So I might be going for a predictive model DT10, which DT10 contained. If we look at the drop term for DT10. We see it contains only weight and abdomen. All of those other measurements are not that important. Weight and abdomen circumference encapsulate all of the predictive power that we can get, or a lot of it, according to AICC and accepting this 3 units of AIC. Okay, what next? Well, you saw that it was quite tedious to write all of these drop terms and updates here. That was doing it ourselves. We can have the computer do it for us. So let's give that a go using some of the built-in functions, and particularly one called step IAC. So get the computer to do the hard work. Why not? Hey, it's what they're for. Especially when doing the hard work means that we can easily make mistakes. So let's go step forward. We'll create a model which is step forward. So step forward means we're going to add variables. Start with the empty model and step forward, AICC. Using AIC as the criteria, we start with model 1, the full model. We're working with model 1, the full model. Direction equals forward. And we're going to say this. We have this other argument which is scope equals alright, we're going to do scope equals, and we have to give it a list. Upper equals fit1, lower equals fit 2. Now I'm going to explain what this means. I'm going to do this by creating fit 1, this thing called fit 1, and that is actually M1 in our case. So it's the full model, and fit 2 is the linear model as before, with body fat as the explanatory variable and 1. And that 1 means only the intercept. So basically this is saying the most complicated model that we'd like you to look at, please computer, is M1, the full model. The least complicated is the model with the intercept only. I just ran those two. They're running. Good. Now we should be able to run that line. Have we got any errors? No, we don't. Good. Now we're just going to do a couple of other, this has actually done the model selection, we're going to do a couple of other model selections first. Another one called step backward. There's not just one way to do this. And we'll do another one called step both. So it's both backwards and forwards. Let's copy that rather than type it all again. Good. We're always using M1. Here we go backward. And here we go both. Let's run each of those. Check out what's happened. All right. Lots and lots of results come out. This is when we've done step both. I'll talk about step both first. It starts with the full model. And what it does is it looks to see, it basically does this drop term to find that ni is the kind of least important variable. And so then it has removed ni. It does a drop term again, finds age is the least important, and so on and so on. Now actually what what both is doing, so as you'll see here it's got a plus, and so here it's put ni back in, so it's kind of dropping one and then it checks to see what if it adds one back, and here you can see it has dropped age, so it's checking to see what happens if it puts age back in, but it's also checking to see what happens if it puts ni back in after it's dropped age. So that's why it's kind of going both. It removes the variable, but also checks to see what happens if it puts one back in. That's different to what happens when we're doing backward. Here we're looking at the backward results. Here we see it's the drop terms, just negatives, just removals, just removals, just removals. All of these are removals. So backwards is only doing removals. And let's have a look at the forward. Forward hasn't actually done anything. I will just pause and check out why. Okay, the reason is that this argument here is the starting model, and we've started with the full model going forwards, as in adding variables, and there's no more variables to add, so nothing happens. What we'll do is here start with fit2. That's the intercept only model. We run it and see that. Go back to the start. Starting point is a model with a very high AIC and only the intercept. That's what the 1 means and nothing else. And here is the add term. It's added each of the variables individually and looked to see what happens to AIC. Good. There's the next one added, the next one added, and here's the model building up. This is the model with abdomen and weight. Abdomen, weight and neck, abdomen, weight, neck, bicep, and so on. And this is where it stopped. It said, oh, I like the model with abdomen, weight, neck, and bicep. It's good enough for me. So it stopped there. Good. Not so easy to compare the results of these models. What we'll do is put them together just like before into a list to facilitate comparison. The step forward equals step forward. Step backwards equals step backward, and step both equals step both. Let's put that on a new line, and then model cell mods to compare those. Put them together. Lost this. There we go. And here we can see those 3 models. One that we've got by this, the computer doing a forward selection, one with the computer doing a backward selection, and one with the computer doing both backwards and forward selection. And the delta AIC among those 3 is maximum of 0.2. The step forward has given a model with the lowest AIC of 1408.3, and it is a model with abdomen, bicep, neck, and weight. This is just abbreviated, it's missing the I. Good, so the automated procedure is giving us somewhat similar results. I mean, we just have to choose when we're going to decide that the AIC is as good as we want it to be. We certainly know that we've got to have abdomen and weight in this model. The inclusion of biceps in the neck doesn't actually change things that much. The inclusion of these other ones doesn't change things that much. So that is some of these functions. Step AIC, getting the computer to do us the hard work.